Good morning, everybody. So we're starting this 3 session on mobile development. The idea is to see how our services and our mobile SDK can be used with Android. This is the Android session. The iOS session is on the other room. To see how it can make really the development of a mobile application easier, because it takes care of some features that usually you have to develop again and again every time you do an application. And it can really help you also to make the backend lighter, because you can directly access from the mobile device our backend services like S3 for file storage or DynamoDB for a NoSQL database. And we will see you can also use this together with Lambda. We will talk briefly about that because we just announced Lambda yesterday, to really create an application that is without a server in a backend, using everything event-driven based on our services. So the idea of this workshop is to show you some real code and to show you also a real application. I'm affected by a bug on my Mac right now, so I am rebooting the Mac. It's a bug with the Yosemite. So for now, we start with the slides, and then we will introduce more code afterwards. So the idea today is to build together one app. And this workshop is split in 3 parts. And we will see some source code, and we will see also how this code can be used in a generic application. I really want your feedback on this session, so at the end I will give you my email and my Twitter handle. I would like to understand what you liked, what you think can be improved. So let's review together the agenda. So I don't see the screen here, so I'm watching here. So the first 45 minutes, we will introduce the mobile services and our SDK, how it works. We will see how we can manage user authentication and authorization using Amazon Cognito. And we will see also how you can synchronize data across devices using Amazon Cognito. So these are the 2 aspects. It's a single service. It covers both identity and data synchronization. And then we will see how this can be seen in a perspective of scalability and cost. So how these services can help you scale down if you don't need you don't have a lot of users, or you're starting a new application, or scale up if you really have a lot of users subscribing to your application, and how costs are related to scalability. The second part, that will be the next 45 minutes, we will see how you can understand the usage of your app by your users, because when you develop a mobile application, you give it to a store, your users are downloading the application, you know how many downloads there are, but you really don't know how your users are using your application. So we'll see how mobile analytics, Amazon Mobile Analytics can help you with that. Then you will see also how you can directly upload and download content from the device to our object storage, to Amazon S3. This is really interesting because managing massive upload or massive download can be costly and difficult to keep up with the scaling and high availability. And you don't need to manage that because you can directly go from the device to S3 in a secure way. And then we will see also how you can directly access a NoSQL database, Amazon DynamoDB. And we also offer an object mapper that allows you using Java notation, and there is the equivalent for iOS. You can just map an object to a DynamoDB item, that is how we call the row in DynamoDB, to make it very easy to store and retrieve data from DynamoDB, still directly from the device. And also we will review scalability and cost for these 3 services and connectors. And the third part, so the last 45 minutes, we will introduce how you can use mobile push messaging. That is the most powerful way you can engage back your user on your application, sending a mobile push, using Amazon Simple Notification Service, SNS, that can do mobile push across different providers. So for Android, it can cover both Google, it can cover Amazon Fire OS device, Kindle device, and in China, it covers Baidu, that is the local provider for Android. And you can use the same API, the same interface, also to send mobile push messages to Apple devices, to Windows devices. So we support Windows 8 phones, Windows 8 desktop, and Windows 7 phones. And after the mobile push part, we will see how you can use your phone to send and stream data in real time to your backend. And you can use it mainly for two reasons. You want to stream information like the location where the user is, so that you can provide localized content to the user. Or you can use it also for debugging. So anytime you have an exception inside your code, instead you don't have control of the device of the user, but you can take all the possible information of this exception and send it back to your backend where you can analyze it and maybe reproduce the bug that produced this exception. We will see, because we will have a very tiny piece of backend to manage in our architecture to run the geolocalized queries towards DynamoDB. I will explain this in detail later. So there will be, we will show how you can use Elastic Beanstalk, our service that is really targeted for developers that allows you to deploy your code and run it in the cloud without having to manage the platform and the infrastructure. And we'll also review scalability and cost for these components. And there will be a final review at the end of this third section to see how we build everything together, how everything is related, because as you saw, we will cover different aspects, different services, and it will be nice to put everything together. So let's start with the first part. So let's start with how mobile services work. So the idea is to build together an application that it's a very simple application in some perspective, but it's nice that we can build it almost without a backend. So we will, this is the view of the application from the user's perspective. So the user will be able to write some private nodes that will be geolocalized, so you can geolocalize them on a map. You can add images to a node that can help you maybe remember something. And if you want, you can make these nodes public so that everybody can see them. Otherwise, they're just private for your own usage. So you see these private nodes and these public nodes on a map. I'm using Google Maps here. And you keep your own state, data, and configuration across different devices. So using Cognito, we will see that the same data, the same configuration will be synchronized across different devices. So here we're talking about Android, but the same application can be on, for example, on iOS. So the user can view the notes during the morning, during the commuting on an iPhone based on iOS, and in the evening on a tablet based on Android. Sorry. Okay, so this describes all that is seen by the user. What is the developer point of view? So probably your point of view for this application. So we will see that we will provide powerful analytics to developers, so to understand which is the usage of the app, so how the user is using the app, which is the user behavior, so the current location, where he's going. And we will support also the information if anything goes wrong in your app when it's running in someone else's phone to get you back the crash dump of the error. And also from a developer perspective, it's important that we will be able to send a notification to your users. We will be able to send notifications in 3 ways. You can send a broadcast notification so the same message to a large population of users. You can send direct messaging, so a specific customized message for a specific user. Or you can do closed loop, so merging the analytics part with the push notification part. You can analyze your users and create segments of your users where you can send a tailored message. So this is starting to be marketing, but it's very important because there's a lot of application out there and you need to keep your users engaged. This is the most common functionalities that you have to develop when you create a new app. So you need to authenticate your users because the users will need to get a customized experience from your app. Maybe you just need authentication for saving user preferences, but you still need to authenticate them. You need to authorize the access. So after authentication, there is the authorization, so they will be able to do something based on their users. And you need to synchronize data because you want to give the same user experience across different devices and across different operating systems like iOS, Android, and Android for Amazon devices. You want to analyze user behavior, you want to track retention, otherwise the user will leave the app and forget to use it. You want to store and share media, you want to deliver media like high-resolution pictures or video content to your user, you want to send push notification, we already said that. And you want to share data in a structured way, so using a NoSQL database, for example, directly from the device. And you want to stream real-time data from your device. We will see that we have services or connector to our services that allow us to do that very easily directly from the device. And to do that, you use our mobile SDK and our mobile services framework. So how does it work? We have mobile optimized services, and they are Amazon Cognito. There is mobile analytics and Amazon SNS mobile push. And we have connectors to our traditional services that makes them their use very easy from a mobile device. So for Kinesis, DynamoDB, S3, SQS, and simple email service, SES. So you can also send directly emails. We will not cover that in this session, but it's quite easy to do. And with this connector, you can interface with our building block services below. So as I said, Cognito can be used for identity and data synchronization. Mobile analytics is really helpful to understand how the user are using your device. SNS can send mobile push notifications. Kinesis can be used to send, even using our connector, even if you have intermittent network connection, data from the device to your backend to be analyzed in near real time. You can connect to the DynamoDB with the connector and save object on S3, send a message on a message queue with SQS, or send email with simple email service. Let's start with Cognito. So this SDK, just to give an overview, is available, as I said, for Android, for iOS. It covers both general Android device and Amazon devices. And it's also available in a developer preview for Xamarin, that is a cross-platform development environment based on C# that allows you to develop once and then distribute through different platforms. So it's quite broad in reach. So let's start with user authentication and Amazon Cognito. So with Amazon Cognito, the basic idea is that you start to manage cross-device and cross-platform synchronization. It really simplifies access management to our platforms, because Cognito will create a unique ID, and this unique ID will be associated with AWS credentials that allows the user to access directly our services with a specific role. And it will automatically allow you to implement security best practices. So we have security best practices that we usually tell, like never put AWS credentials inside a device, inside an application, because they can be stolen. And using Cognito, all of our security best practices will be automatically be implemented. So it makes life easier also on this side. How Cognito identity works. So the idea is to shift authentication from device to the users. So normally you authenticate a device. The idea here is to authenticate the users. How it works? So the identity providers that we support are social login, like Facebook, Amazon login with Amazon, Google. We support OpenID Connect, and we also support your own developed identity, so you can create your own authentication system if you want. The user can authenticate from the device towards one of these identity providers. We recognize the same user even if it's using different device, and then we can merge the identity of the users. And then the user will get AWS credentials that can be used to access directly our services using the connectors that I described previously. So the first thing that is important is that Cognito starts to recognize users even if they are not authenticated. So when you have an application that starts, you don't want the user to authenticate as the first step, because it's a bad practice. The user will maybe drop the application as soon as you ask them to do a login. So you can start non-authenticated. Of course, these guest users will not be recognized across different devices, but they can start to use your application and maybe save personalized data that will be then merged to an identity when they do the authentication later on. To start using Cognito, it's quite easy. You just need an AWS account. In our console, you can create an identity pool. An identity pool is a pool of identities that share a common configuration framework. And then you need to download the mobile SDK and include it into your application. So now there should be the first demo, but as I told you, we have a small bug, so I will take 2 minutes to try another reboot of my Mac. So I'm deeply sorry for that. And then we move on. Jan, maybe we can use your Mac for showing the console. No, for now I just want to show the web console. So.
Problems have another signature.
I will check that afterwards. So, 1 moment of patience. Okay. So let's. Where there was another. I can use the other connector, so you can switch. I need a console. So can we switch on the other device? Can I do it from here? Yeah. Okay. So let's log in. So let's start with the mobile services. And we see there is Cognito, Mobile Analytics, and SNS. Let's select Cognito. So with Cognito, you have the identity pool that I mentioned. So this is the identity pool that I would like to use for the live demo. Let's see if we manage to do that. And this is the configuration. So when you create an identity pool, you have this console when you see how many different identities were being used, for example, in the last month, how many data synchronization there have been, the storage that has been used. This is important because synchronization and storage, we will see, is what you pay for using Cognito. Then you see which kind of authentication the user are using. So most of the users are not authenticated, and then you have a few users that use Facebook login with Amazon. And you can imagine that this single user, it's actually me when I was testing the application. And from here, you can edit the identity pool and see which is the configuration of the identity pool. So when you create an identity pool, you give it a name. You get a pool ID that is what you will use in the source code. And then you have the configuration of the identity providers. So you just configure Facebook login, login with Amazon, or login with Google normally with your application. And here you put what you get back from this provider when you configure the application. For the app ID, for example, in case of Amazon and Facebook, as I did in this application. Here you can enable OpenID Connect providers. This is an option. For example, Salesforce is using that. So if you want to develop an application that can merge identities with Salesforce, that can be a good option. We have a full example on our blog. Here you decide if to activate or not non-authenticated identities. So if you want to trace the users as soon as they start to use the application, even before they are authenticated or not. And we will see which is the impact of that. And here, this is a new feature that we released last week. You can activate push synchronization. So if you activate push synchronization, when a device is changing something and is starting as data synchronization, all the other devices that are using the same identity so the same users on other device, will receive a mobile push notification that you can intercept and use to start your own local synchronization of data. So in this way, you can really synchronize in almost real time to devices. And this is also reducing the cost of Cognito, because in this case, you don't need to run a data synchronization every, I don't know, half an hour to be sure to be in sync. You only run it when you receive this notification, or when you log in to a new user ID, so the user ID is changing. So in this case, you reduce the number of data synchronization and the cost of the services. So in this case, you have to configure this service role is the role. Are you familiar with identity and access management from AWS? Just a few words on that. So the identity and access management is our security framework, and all of our services are based on that. You can create roles, and roles can be assumed by a user to do something on our platform. So this is the service role that SNS will assume to send you the push notification. It's automatically configured when you create the identity pool the first time. And of course, you can delete the identity pool if you want to start from scratch, but this is quite dangerous. Okay, so we saw the console. So to switch back, push 5. We're improving little by little. So let's talk a little bit about Cognito security. So the idea of Cognito is to help you use our credentials in the best way. So in this way, you get AWS credentials using our STS service, the token service. So the device will get credentials that are temporary with a limited time of life, and then they are automatically refreshed by Cognito. So it's quite interesting. It's something that you could do also without Cognito, but it will require you some development and to create an identity server running somewhere to do the same thing that Cognito is doing for you. So this is the overall architecture. So you have the device on the left running the application with the Cognito code, and you have the identity providers that are external. So you have just to manage a normal authentication towards Facebook, Amazon, or Google in this example. You get back an access token that has a different name depending on the identity provider. It's called OpenID token or out token, but it still is a token. Then you go to Cognito, and you from the device, and you tell me, I got this token from this identity provider, let's say Facebook. I want to connect to this pool ID, so the pool ID that we saw previously when we saw the console, and I want to assume this role. So this is another identity and access management role. It's the one that will be given to the device in order, for example, to access S3, so to upload data. What Cognito will do, will check if the role has a trust with that pool ID, and we will see that later on. And if the role has a trust with that pool ID, we'll verify the token with the identity provider to be sure that the login was successful. If the token is correct and the role can be assumed in that pool ID, then the Cognito will give back a unique Cognito ID in the temporary credentials that the mobile can start using to access directly AWS services. So now the device can go directly to DynamoDB, to mobile, and to other services. So this is the overall framework. It's important that the authentication is the first step in this completely separated from Cognito. Then when you have the token, you go on and talk with Cognito. As I said, you can also use a developer authenticated identity, so something that you develop directly yourself. And in this case, the only thing that you have to do is to implement the get OpenID token for developer identity. So you do your own authentication based on your own database, your own directory server, your own repository. If you check that the login is successful, you ask Cognito server-side, so with a server-based authentication, so it's you usually use an EC2 role here, to get an OpenID token. And then you get this token back to the user together with a successful login. So you say to the user, you have been authenticated, and this is your OpenID token. Then this token will be used exactly as previously to ask Cognito, I want to log in this identity pool, I want to assume this role, and so on. So the only thing that you have to add if you already have your own identity system is this callback to Cognito and to return the token to the user. So yeah, this is the flow. You get your authentication system gets the OpenID token back, and then the user will use this OpenID connect token to get back the temporary credentials. So exactly the same workflow as before. So I mentioned more than one time that with Cognito you get on the device an identity and access management role. The important thing is that the security profile that you can create in this role is really fine-grained towards our services. And this allows you to directly access the services from the device. So this is the overall scheme of how it works. So an AWS account can have one or more identity pool. Usually you have an identity pool per application, but there can be exceptions. And then this identity pool will have authenticated and non-authenticated identities. And each group, authenticated and non-authenticated identities, will have their own roles that allow them to do something, like in the example that you see below on the right, like they can get and put somewhere in S3, or they can get and delete from DynamoDB. This is the access policies that is bound to the role. Let's see an example. So this is something that you will, I hope, never do in reality because it's giving a powerful role to a mobile device, but let's start in this way. So as you see, the syntax of a role is with three parts. Actually, there's a fourth part. So first you have to define the effect, that is allow or deny. By default, a new account cannot do anything. So usually you have allow rules. If there are two rules, one allow rule and a deny rule that affect the same set of resources, the deny will always win for IAM. So, but usually you use only allow. So the first rule will give allow to a set of actions. In this case, it's S3 star. It means all the possible action that you can do with S3, like create a bucket, delete an object, whatever, and on any resource. Actually, you can add a fourth line that we will see, that is the conditions. The condition can add a more fine-grained control. We will see that for DynamoDB. The second rule is similar, but it will deny any action on DynamoDB, because DynamoDB star is the action. And the third line will allow the usage of a Cognito Sync, so data synchronization, on any resource. Actually, Cognito Sync is a little bit of an exception, because to make things simpler, you can use star as a resource in the configuration of the role, but we will check that you are actually accessing only your own specific data. And if you want, you can replace the star in the resource with a very long line that we can provide you, that it actually tells that you only access your specific resource, but we do that automatically, so it's maybe easier to manage. Now things start to get a little bit more interesting, because in this example, what we do is we give access only to a specific set of actions on S3. So if you see there is put object, get object, so put and get, delete object, list multi-part upload parts. It's used to see if you have an upload splitted in parts that is ongoing. And you can stop a multi-part upload. And you can do that only on a specific resource that is a single bucket. So bucket name /star means a single bucket, whatever is inside this bucket. So for example, this user will not be able to create a new bucket because create bucket is not in the list of actions. The second group will allow list bucket and list bucket multi-part uploads. So it's probably something that it's less dangerous to give, because they can only list what's inside a bucket. And the third rule will give access to a specific table and to a specific index in that table for DynamoDB to get item, so to get a specific item by primary key, to query, it will run a query, and of course, and put item to add an item into that table. So from the star in the previous example, we are starting to do some fine-grained access control. But things can also can still improve. In this example, for example, you give access only not to a whole bucket for S3, but only bucket name / Bob. So you are specifying a subdirectory, a virtual subdirectory for S3, Bob, where the user can upload and download maybe his own files. The list bucket is running only on if the, you see we are using here a condition, so there is effect, action, resource, and condition. The condition is that the prefix is starting with Bob. So this is an example of a condition in a security policy. The third one will give just access to the list bucket multiple uploads. And this is the final example. That is probably the real one that we will use in an application that is using policy variables. Policy variables are really powerful because they can replace inside a security profile the unique identity ID that Cognito gives you, and also the authentication scheme. So the first rule, this is an example of a fine-grained access control for Cognito Sync, will tell that you can synchronize only a specific identity pool. So this is the everything that starts, you see under resource there is ARN. Everything that starts with ARN is an Amazon resource name, so it's a way we use to identify a resource within AWS. So only that identity pool / there is Cognito identity Amazon AWS.com AUD. AUD is the authentication provider. So if you use Facebook, it will be replaced by the authentication scheme of Facebook. This graph.facebook.com is something that you know if you do Facebook authentication. If you use Amazon, it's replaced by something Amazon.com and so on. And /identity / there is Cognito identity Amazon AWS.com sub SUB, and this is the unique Cognito ID. So you create two folders, one where you specify the identity provider /identity, then / the unique identity of your user. And something similar in the other example. The other one is maybe simpler. Usually you don't need to split your users across different authentication schemes. Maybe the second sample is just you can access my bucket / Amazon / snake game, that is maybe in the name of your game, / Cognito identity, the user ID. So that part is replaced automatically by the identity of the users. So if you see, you can start to create a specific section of an S3 bucket where you store only the data of a specific user. Okay, this is the first part to introduce how identity works. Now let's see how data synchronization works. So data synchronization is something complex to implement. I don't know if some of you try to implement their own synchronization scheme across different devices and different operating systems, but it's something that the user really needs, because the user, they want to have their own user preference anytime they start the app, even if they change the device. So just think of a very simple example that is a game. If I buy a game for my iPhone and I reach level 3, if I could buy the same game maybe for my Android table, because on my tablet it's larger, I can play more easily on my sofa during the evening. But I don't want to replay the same levels. I want to start exactly where I left the game on my mobile device, and maybe the next day I will switch devices again. So data synchronization is important and must be implemented. What we provide with Cognito Sync is a private data store for any user that is a key value store that you can access from the device, and you can store not an unlimited quantity, because it's something that you want to synchronize over the network. So the sites must not be too big, and then we will see which is the size limit. But this data is cached locally so that you can work even offline. So you run the synchronization, cache data locally, and then use the data. This is possible because we use the local SQLite database that both iOS and Android are providing as part of their operating system. So every time you run, you save something into this from the application into the key value store that Cognito gives you, you are storing data into your SQLite database. When you run data synchronization, it will compare the status of the local data with the centralized data stored in the cloud. it will merge the difference. We will see better what that means with a real example, and save the updated data into the local light or the cloud, depending which is the most updated record. There is a flexible conflict resolution because we have a callback that we give when the same record has been changed both locally and remotely, so that you can handle the conflict. We provide you the last update date on both records, so maybe you get the most recent one, or you can access the data and maybe implement your own logic depending on what the data means for your application. The fact that we use the local cache means that Cognito is very fast and you don't need network connectivity. This is important. So this is the schema of the data model. So an AWS account can have one or more identity pool, as we said, probably one per application. Each identity pool will have one or more identities, and we don't have any limit in the number of the identities that you can have. This is corresponding to the users. And by the way, you don't pay by the number of identities. Then each identity can have one or more data set. There is no formal limit in the number of data sets, but each data set must have as a maximum size of 1 megabyte, because it's what you synchronize over the network. We don't want to have too many data to synchronize, otherwise the synchronization would be slow. So you have 1 megabyte and 1024 keys inside a data set. The name of the keys, you can choose whatever you want, but the number of the keys must not be more than 1024. And then, and this is the key value that you can store. There is also another limit that is by identity, so a single user cannot have more than 20 megabytes. So you can have more than 20 data sets if they are smaller than 1 megabyte, but the overall size of the user cannot go beyond 20 megabytes. So this is where you store user preference, metadata. You will not store images or media content here. You use S3 or other services, and maybe here you store only the link to the media content. So let's see an example that is a little bit more complex. So let's say that we create a single identity pool. And with this identity pool that is maybe authenticated by Facebook, we create two data sets. One is a user preference data set that is shared between two applications, because these two applications will use the same identity pool. So in the user preference, you can say maybe the language or anything that is tailoring your content for the user, both for a productivity app and a game application. Then the game will have its own state, so you create a second data set with the game state. In this way, the user maybe is starting with a productivity application. It's choosing its own favorite language, time zone, or whatever. When he plays the game, he will find anything already configured. He will not have to change anything. And we will also start to save the game status and everything there. So this is the code that hopefully we will also see running live afterwards. So this is the code for Android, so how you initialize the Cognito provider. This code is actually presented directly from the console. So when you create a new identity pool, the console will create all the code that you have to cut and paste in your application. This is something that you would usually put in the onCreate method of the main activity of your Android application. So this code will start, and you have to configure. So you create a Cognito caching credentials provider. You have to specify the context of the activity, the account ID for AWS, the identity pool ID that we saw, the long string. And then you have to specify two roles, the non-authenticated role and the authenticated role. We will see later that when you configure the role in the identity access management system, you actually have a trust. You have to create a trust between the role and the identity pool, and you can configure if this trust is based for authenticated or non-authenticated identities. This is important because if you switch these two roles, you give the authenticated role to non-authenticated users, and usually the authenticated role is more powerful than the non-authenticated one. So this is very important. And this trust method allows you to be sure that a user only can get a role he is allowed to get. And then you have to specify the region. Cognito is currently running in US East 1 and in Dublin in Ireland. So if you have American users, probably US East 1 is the correct region. If you have users in Europe, maybe because you want the data stored in Europe, that can be also an option. And as you see, as the return of this, the return object that you get is the Cognito provider, and you can get the identity ID, so the unique ID that Cognito gives you after this login. This identity ID is unique, it's fixed, but when you merge two identities, so you start non-authenticated and then you log in with Facebook, if we have two identities that we recognize as the same user, then we will have to decide. So Cognito will choose one of the two identities, and when you run after a merge, a get identity ID, the identity ID in one of the two devices will change because, of course, only one can be used at one time. And then this Cognito provider object can be used with all of our normal APIs to create a client that can connect to the services where the role gives access. So for example, here we create a DynamoDB client with this Cognito provider. So if the role that I get allows me to do something on DynamoDB, I can go and do anything. So this first part was Cognito identity. Now we see how it works, the code for the Cognito synchronization system. So you get the sync client, the Cognito sync manager, passing your Cognito pool ID, your region, and the Cognito provider. Actually, last week we did an update, so you don't need anymore to specify the Cognito pool ID in this call. You can just call the Cognito provider. It was a redundant information. So this has been shortened a little bit. Then when you have the sync client, you can use the open or create dataset to create a local dataset that you can access as a key value store to store user preference, data, whatever. When you have the dataset, so it can be a new one or can be a dataset that is already there, you can just use put and get and remove to work on the dataset. So you can put my key, my value, you can get the value back, and you can remove. As you see, everything is a string. So of course, the suggestion is usually to use JSON object, so JSON syntax to put a more complex object inside a dataset. When you have accessed a local dataset, then you can synchronize the dataset. You can do that because you received a pull notification that something has changed, or you can do that because it's the start of the application after some time, so you want to synchronize the data. And you have two calls, synchronize and synchronize on connectivity. So synchronize will run the synchronization over the network, but of course it can fail, and you have to manage the exception if there is a moment where there is no network connectivity. But there is the second one that you can probably always use, that is synchronize on connectivity. If there is no network connectivity, it will store in the shared preference of the application that the next time that there will be network, Cognito will start a synchronization. So as soon as there will be network, there will be a data synchronization. You only have to be careful if there is some garbage collection of your activity. You could potentially lose this information, and the data synchronization will not run automatically. But this is really something that happens if the user will put the application in background for a lot of time. This is how Android handles garbage collection. So as we started, and we saw how we can use Cognito to manage identity, to manage the access management towards the services, and also for data synchronization. Let's review together the scalability and cost. We are really almost on time here. So can you, let's see, we can review quickly. Where is it? Yeah. We're starting to work. So let's see. So let's talk about scalability. Using Cognito, think that swapping the cable will be faster. So let's. Okay, so scalability. For scalability, everything is managed by AWS, so you don't have limits in the number of users, number of authentication. It's really, there is no limit in the scalability that you get from Cognito. The only exception if you have your own developer managed authentication. Of course, that's something that you have to build and you scale it by yourself. So if you can avoid that, of course, it's better. Talking about the pricing, this is what you pay. So you pay the storage and the synchronization. So first of all, you get 10 gigabytes of storage for the first year. You get, this is only for the first 12 months, you get 10 gigabytes of storage and 1 million of data synchronization per month for free. So if you start using Cognito for the first year, it's quite difficult that you start to pay something. And after that, you pay 15 cents for every 10,000 synchronization from the device and 15 cents per gigabyte of data that is stored and synchronized in the data sets of the devices. So as I told you, data synchronization is one of the two parameters for cost. So using push synchronization, it can really reduce the number of synchronization because you only run the data synchronization when you know that something has changed in a data set of the same user. And you can really reduce that number a lot. Push synchronization works also when the application is shut down because you will still receive the synchronization. And you can manage that storing, for example, a shared preference. And when the application will start, it will check if a notification arrived or not to eventually run the synchronization. So with that, I think the first section is concluded, and I'm sorry for the issue with the demo. I hope that for the second part it will be more interactive, but I think there was a lot of information. I hope it was useful. So we start back in less than 15 minutes. Thank you. Okay, so let's start with the second part. So in the second part, as I told you, we will focus on how to understand the use of an application by your users, how to upload and download content directly to Amazon S3, and how to store and share data from the mobile, structured data using DynamoDB directly from the device, so a database. And we will introduce the use of the object mapper that allows you to do that very easily because you can just annotate your object and it will be mapped into the DynamoDB schema. And then we will review scalability and cost. So let's start with mobile analytics. So mobile analytics is one of the most used tools by developers. This is an analysis that is quite interesting by Vision Mobile. It's frequently updated. This is the last version. I suggest you to have a look at it. What this analysis tells us is that on the right, you see the 10 most popular tools that the mobile developers are using. And by chance, the second one is cloud computing, and there's also user analytics in the top 5. And on the left is showing another interesting thing, that is how many tools developers are using. And these are the different bars, from 0 tools up to more than 10 tools, and how that is affecting their revenue. So the red bar means how many applications from those developers are below the poverty line of $500 of revenue per month. That is the usual standard that is used for this kind of analysis. So as you see, developers that are using no tools or very few tools, they have a large quantity of applications that are below the poverty line. As soon as they start to use more tools, they become more productive and the application generates more revenue. So this is a suggestion. Don't try to develop everything by yourself. Use tools because you can then focus on the unique features of your application and you don't have to re-implement the basic stuff. And in particular, you see cloud computing and user analytics are among the top 10 most popular tools. What customers told us is that they want to know what the users are doing with their application. They want to know that very quickly. They want to know that as soon as possible so that they can react. And they want to also own the usage data because this is important. So for that, we have Amazon Mobile Analytics that can help you collect, visualize, and understand your app usage at any scale, and can do that in a very easily because you just need to create an application in our console. We generate the code for iOS or Android that you can put into your application, and you get the standard metrics out of that. So it's very easy. You still need to use, of course, the mobile SDK. So let's see how you, this is an example of the code that we generate for Android. So you have to create an analytics object, and then you can initialize the object with these few lines where you specify the app ID, the Cognito provider, so you use the authentication for Cognito here, so you get the Cognito credentials and you use them here to analyze, so Cognito must be called before this. You specify the region, and you have the mobile analytics app ID, that is the unique ID that we generate when you create a mobile app. Then you have to put into the on pause and on resume, that was on create, of course, of your activities, this code to pause the session and start the session again based on what your users are doing. As you see, there is a submit events call. That's when the client will send the events to mobile analytics to be collected. And what we do, we will analyze and present the data in less than 60 minutes. So in less than 60 minutes, the data from all your users will be in the dashboard for mobile analytics. This is a more interesting example because other than normal metrics, we will see that in a moment, you can also create custom events that will trace specific behavior for your application. So for example, you can create your own method on level complete. This is an example for a game. So when the level has been completed, you create a level complete event where you can add attributes and metrics. So this event will specify which is the level name, the difficulty that the user chose for the game, because you can play maybe the game with different levels of difficulty, and the time to complete that is not an attribute because it's a number, so it's a metric that the user took to complete this level. So you create a specific event. As you see, you can also add attributes afterwards with add attribute and add metrics as well. And then you can get the client and record the event, and this will store the event locally. When you do the submit events, this will be sent to AWS for analysis. So this is very, as you see, when you implement a method like this, then you can call very easily the method in different parts of your application. And this way you can trace which level the players are playing now. For example, this is very important because maybe you release a new level and you see that people is not engaging with your application anymore. Maybe the fifth level that you release is too hard. Nobody is completing this level, and they just get annoyed and stop using your application. This is giving you the feedback because you understand that everybody is playing up to level 5 and then they drop the usage. If you want, you can have specific events that can be tied to all user interaction events inside your application. So if you push a button, if you click on a map, if you drag something, you can generate an event that you can trace. And this is interesting because if you develop a new feature for your application, so you create a new feature in a new version of your application, then you give the application to the App Store, you don't know if the user are actually using this feature or not. So, for example, with a specific custom event, you can trace back this behavior and see if the user are actually using your new feature. And if you have a multi-step feature, this allows you to see where the user stop using this feature. Maybe you have some workflow where the user will buy something, and you see that people is not buying the content that you are selling. Maybe here you discover that in the third step, when you ask a specific question, users drop this workflow. So maybe that's something that you must improve in the workflow of your application. We are also integrated with the stores. So this is an example for Android with Amazon App Store and with Google Play Store. So you can create monetization event when you have, for example, an in-app purchase inside your application. In this way, you can trace the product that has been acquired, the price that was paid, and the quantity of the object. And this will go in the reports that we generate for you. This is an example of the console, but I would really love to show you a live console. So let's see if I manage to do that. Okay. Red button. It works. So mobile analytics. So this is the application. We can see all the application that I have, and you can see the integration steps. So you can see that we generate the same code that we just saw for iOS. This is the Android. This is telling you also which are the jar that you must include from the SDK. Of course, you can get the debug version of the same jars. The user permission that you must put into your Android manifest file. You need internet access and access to network state. The import, and this is the Cognito credentials provider. We saw it to get the credentials from Cognito. Here you initialize the object, and then this is the exact code that we saw in the slides. So when you put this, you can see the reports. So this is the reports that let's use the last month. So there's not a lot of users because it's my application, but it's interesting to see the metrics that we can get. So one important metric for an application is the daily active users, so the unique users that every day use your application. So you have the identity from Cognito, and we see how many distinct people is actually using your application. And the same you can get as a monthly active user, so the unique users in a month that will use your application. If you think of these two numbers, the monthly active users is always greater than the daily active users because it's across 1 month, and it will include, of course, the users in 1 day and maybe different users that use that application in a different day. This is interesting because you can get the ratio out of this number. So the daily on the monthly active users is the sticky factor. This sticky factor can be close to 1 or very small, close to 1/3. If it's small, it means that the daily active user is smaller than the monthly active user. So a few users use your application every day, but they use it every month. So it means that they use your application occasionally during the month. 1 day, yes, and maybe for a few days they don't use your application. If this ratio is close to 1, it means that they use most of the days your application. So the users you have, they are loyal to your application. This is a very small and tiny number, but it tells you a lot on the behavior of your application. And then you also have the new users. So the new users that every day start to use your application. And you have the retention. The retention, we also have a specific panel. And here we have also a summary of the revenue if you use the monetization events that we saw previously. Let's go to the retention. There are other information, you see there are different panels, but one of the most important is the retention panel that tells you how many users that are using your application now also used your application 1 day ago, 3 days ago, 7 days ago, if I remember correctly, 1 week ago, and 2 weeks, yes, 1 week and 7 days is the same, 2 weeks ago. So this is important because most of the mobile application now, they are downloaded, used the very first day, and then forgotten inside the mobile and maybe deleted when you need more space. So from the retention, you understand if people are actually continuously using your application, or after 1 week or 2 weeks, they stop using it. And this can be used together with mobile push to engage your users back. So if you discover that after 2 weeks, people using your application stop using that, you can get the list of the users that are doing that to send them maybe a mobile push notification that will engage them back on your application. Or you can also understand that you need to develop more content. If you are developing a game, maybe after 2 weeks they end everything that is possible to do with your game, and that's the reason why they are stopping using your application. This is the interesting panel, is the custom event. So as I mentioned, the idea of this workshop is to build this application that maybe we will be able to see or not, depending on the will of my Mac. But I already have some data collected. So what I did, I used specific events for any UI interaction that you can have with the application. What does it mean? It means that if you for example, insert a new node, you remember the application is to create geolocalized nodes. You have a graph that will tell you how many nodes has been created every day. But when you create a node, you can also create the node with different interface in my application. So what we did is I created an attribute that I called using. And this attribute has two values, button or long click. So this, if I select a button, I see all the nodes that has been created using the insert node button that will automatically use the location where you are. If I see the long click, this is a long click is an event of the map. So if you push on a map for 1 second, it will create a node in the specific location on the map where you push this click. So in this way, you know if they use the button or if they are using the long click event. And this is interesting because maybe at the beginning you start with only the insert node button, then you want to do something different like a map interface, but you don't know if your users are using this feature or not. In this way, you immediately have a feedback. Maybe if they don't use it, you can decide to send a mobile push notification saying to your users, we just released a new feature, and you now can create a new node just pushing your finger on your map for 1 second. So this is an example. There are other examples here. For example, I added the possibility to drag a node on the map, and I want to know if this feature is actually used by my users or not. I just attach an event to this, and I get the information. And there is also an idea on message received. So when you receive a notification and your application is not running, they are stored in the background by my broadcast receiver. And when they store it, you have a count. And when the application will start, we'll count how many messages. So with this metric, you know how many notifications you sent has been received by your users when the application was not running. And then you can think, maybe I'm sending too many notifications because when they start the application, I found 3 notifications every time, and maybe it's not productive for my users. It's only creating confusion. And this is an example of what you can build with this tool very easily. And here you can see the missed messages. Okay, so let's go back. Okay, so we saw the live console, so this is redundant, but it's important to see that you really are getting business metrics out of this console, and all the metrics, with the exception of the custom events panel, are automatically populated by the few lines of code that we saw at the beginning, the one that are proposed by the console. You don't have to introduce anything new. You just have to introduce those few lines. As you see, you can also download the CSV of the graphs, and the CSV will contain the aggregated data that is displayed by these graphs. But we announced that we are going to release all the raw data collected by mobile analytics, so you will get all the singular granular used, storing that information on S3 and Redshift. Is that right? Yes. By the way, I made a mistake previously. I said that there was no limit in the number of data sets per identity. There is actually a limit, it's 20 data sets per identity. Just rolling back to what I said. I made this mistake, sorry. So one important panel is the retention panel. As I said previously, here you can really understand if the users that download your application are continuing to use it or not. So this is very important. And the custom events, we saw a lot of examples, so you can use them especially with games or with any interaction that the user do. And you have to think of the logic of events, attributes, and metrics, because you can map multiple dimensions. Okay, we already saw the mobile analytics console, so I will go forward. So we are starting to cover the aspects on the right we saw in the beginning. So we know how to authenticate, authorize access, synchronize data. Now we know also how to analyze user behavior and to track the retention of my application. As you saw, everything was using very few lines of code that were automatically generated by the console. So probably saving a lot of development time here. Let's talk about S3. I expect most of you to know how Amazon S3 works. Just a few words. So Amazon S3 is an object storage. You have buckets that are logical groups of data. There is a hard limit per account. There is 100 buckets per account, so you cannot create one bucket for every mobile user. So you need to use the policy that we saw at the beginning, so split the bucket into different path prefixes, each one for each account. To use S3 directly from the device, we introduce one of the connector of our mobile SDK that is it's implementing the transfer manager. The transfer manager will allow you to send, upload and download data directly from the device using the Cognito credential and the Cognito role that we saw previously, so you can give a fine-grained control on this. And it will automatically manage retries, both in upload and in download. So in download, it's easier because we are using HTTP range gets to retry if there is an error in download. But in upload, we are using the multi-part upload feature of S3 that is not very, very easy to implement by yourself, because you have to create a multi-part upload, then run then you have to do the upload of the parts, and then you have to close the upload and to reconcile all the parts. Everything is managed automatically by us, and the upload will run in background. So you can start an upload of a file in the main thread of your application, and in background the upload will start. So it's quite convenient. This allows you to upload large files like high quality, high resolution images, and it allows you also to upload video that it's usually not easy to do from a mobile device. And there is a callback that we will call at the end of the download so that you know that the content has actually been uploaded, so that you can react to that into your application. So let's see how that works for Android. So you have to create the transfer manager object with the credential provider given to you by Cognito. Okay, it's managing the credential. And to upload an image, you have to do transfer manager upload, specify the bucket name where you want to do the upload, the file name, so the key on S3, and the local file object that you want to upload that can be on the SD card or on the local storage of the device. And for download, it's the same. You have to download the bucket name, the key on S3, and the local file where you want the download to be saved. This framework allows you also to pause and resume the downloads. So this is an example for a single download. So when you start a download, for example, you get a download object, and this download can be paused, and you get a persistable download that you can then later on resume and start again. So for example, you can manage this if you want to manage network interconnection by yourself. I'm thinking of when you have a high number of retries, maybe it's useless to go on and retry. Let's wait for 1 hour. Other than that, you can also set up content delivery. So S3 is very powerful for private content that you upload and download. But if you have the same content that must be provided to a large number of users, probably you should set up a content delivery network, because it's much more efficient. It's cached in a distributed on the territory, and it's closer to your users. So for that, we have CloudFront. CloudFront is our content delivery network. You can create a CloudFront distribution with your S3 bucket as the origin. The origin is the technical name for a content delivery network where your data resides. And it's very easy to use, because you just need to replace when you download directly from S3, so you cannot use the transfer manager in this case, but you have to use any HTTP download. You have to replace the bucket domain, so bucket s3 Amazon AWS.com, with the distribution domain that is created automatically by CloudFront. Or if you want, you can replace this distribution domain by your own domain configuring the DNS. How CloudFront works? CloudFront works with a distributed network of edge location that are distributed all over the world. So the first time a user makes a request, it will not use the S3 domain, it will use the CloudFront domain. So we will redirect the users to the closest edge location. If the edge location has the content in its own cache, it will be given back to the user very quickly, low latency. If the edge location has no content, because it's the first time a user is asking for this content in that edge location, it will be retrieved by the origin, in this case Amazon S3, but can also be any web server inside AWS or outside of AWS, and cached locally. The cache can be configured with a specific number of days, or you can use HTTP cache control headers to tell how much time the content must be cached before a refresh. This is the current network. We have 52, if we didn't add more edge location distributed across the world. So even if your bucket is on the east or the west coast in the US, when a user from example from Japan or for Asia is asking for content, it will be cached locally, and the next user will find the content locally. So it's very easy, and so the main difference with S3 is that you don't have a security framework here to control who downloads what, so it's very good for public content. You could have private content with CloudFront, but private content with CloudFront is using a key pair, so you have a public key, and you have a private key, and we have a public key that we distribute across the edge location. So you can sign a URL with your own private key, but this is not working inside a device, because to make it work for a mobile device, you should have the private key inside the mobile device, and this is something that we are not suggesting, of course. So to use this kind of framework, so sign URL with CloudFront on a mobile device, we advise you to have a servlet, so to have a server, sorry. To have a server that with a very, very simple API will sign the content for you. And we add a lot of features to CloudFront in the last year. So we now have mobile device detection, so it can recognize if the request is coming from a desktop, from a tablet, or from a smartphone. And you can use this as a cache key to provide the specific content. So maybe the smartphone will get a lower resolution image than the desktop user. Geotargeting, so you can specify, you can have a cache key populated by CloudFront that contains the country where the user is located when it's making the request. So if you have a copyright issue, you can decide to not serve the content to specific countries because of copyright, you don't have the copyright. You can implement cross-origin resource sharing for JavaScript. This is useful if you want to run JavaScript with different domains. So you can specify the other domain via cross-origin, the origin header. You can have protocol detection, so you can serve some content. So you can get, you can specify if the content can be served in HTTP or only in HTTPS, because maybe it's premium content. You don't want to make it on the networking clear. And we have a lot of features that we added for security for SSL. On one side, increasing the security of the SSL configuration, like using security ciphers that are highly secure, but also to speed up SSL itself. So like OCSP stapling and session tickets allows us to serve the content more quickly. For example, stapling allows us to validate the certification authority without making a request every time to validate the authority. And session tickets allows a user to have a ticket that can be reused for the SSL connection after some time, so you can reuse the same connection. SSL has an initial negotiation that is quite slow, so the session ticket can speed up this kind of negotiation. So now we see how to store, share media, and also deliver media on the device. Yeah.
So thank you very, very much. My name is Dinesh Varya, and thank you very much for coming up bright and early for the workshop. We have some good news for all of you. For those of you who are in the room, and because Danilo and Gian have been helping us, we'll be giving away Fire phones to each one of you. So that is and we apologize for the demo not working. We'll try to do the demo on our other laptop so that you get the chance to work on it as well. I'm going to distribute these kits, these cards. So this will be available at the end of the workshop, and so at around 11:45 or so. So thank you very much.
So I was taking this minute to try a new reboot. I think you will imagine me after this workshop fighting with this Mac. Okay, just 30 seconds and we have a new try. So I think it's interesting that we are building up our application, even if still on slides, not on Eclipse as I would have planned. But we are adding feature and features. So let's see now how we can use also DynamoDB from the device. Yeah, maybe I will show the code. So DynamoDB, how does it work? DynamoDB is a NoSQL database completely managed by AWS. You can create one or more tables. Inside this table, you can put items. And each item will have a primary key that can be a single hash key or a composite key with an hash key plus a range key. Just to give you an example, you can use this simple framework to model a social network. So you can have a user table where the hash key is the user ID, and then you can add attributes. The schema of DynamoDB is flexible, so you can add one or more attributes. For example, I don't know, the birth date of your user, some user preference, and anything that can relate to the user identity. And then you can have a second table that for a social network will keep the links across the users. So in this case, you can have a table where you have this user is a friend, for example, of this other user. In this case, unless the user is a very lonely person, you will have more records with the same user linking to different users. So in this case, you don't use an hash key, but you will use a composite key. So the hash key plus the second user will create a composite key that allows you to model this kind of data in DynamoDB. And this is very useful for a mobile application because it allows you to build one of the key trends of mobile application that is the social leaderboards. So historically, applications like games were providing you a leaderboard with the best results across the world. But people notice that now that there are millions of players, when you see that someone has 10,000, the same score, 10,000 times your score is not really engaging for users. So the social leaderboards will only show you the results of your friends. So you authenticate, for example, via Facebook, and Cognito will manage that to merge the identity. You allow to see the users. So the first time you will have some probably server activity that will download from Facebook your friends. We'll check if these friends are present for this game, so authenticated in that identity pool, because when you authenticate, Facebook will give you the user ID. And you can have this table with this user as these friends on this identity pool. And then you can use DynamoDB to run queries that will extract the score of your friends, sort it, and show a social leaderboard. So this is something that is really not very effective on large scale on a relational database, but with DynamoDB it's very powerful because it can implement it very easily. And you can run most of these queries directly from the device. You can use the DynamoDB client, so you can access items, attributes, you can run queries towards a specific index. But you can also use the object mapper. The object mapper will make your life easier because with the object mapper, you can create a table that will just map an object into the content of an object. So let's see an example for a book. So let's see that you want to store on DynamoDB a table that is a bookstore that will contain some information for specific books. You can create a book object, so this is plain Java, with Java annotation for DynamoDB. So you specify that this book class is using a DynamoDB table that is called bookstore, and then you specify for getter and setter that you have into your code if they are related to an attribute or no. There's also an ignore tag that you can use, an ignore annotation that you can use to say, okay, this field is not important, I don't want to save it on DynamoDB. But in this case, we are mapping the hash key, that is the book ID, into the attribute name ID, and then you are mapping the ISBN into the the attribute with the same name. When you do this kind of mapping, then you can build a book object from scratch. You can set the values using the getter, the setter that you implemented, like the ID, the ISBN, the title of the book, a Boolean flag that tells you if it's an hardcover or not. And then you can save the book object to DynamoDB straight with a save. So it's very, very easy to implement. And you can also update the book and save it again. Since the primary key is the same, it will overwrite the previous record. Or you can load a new book using the load of the mapper. So this is DynamoDB using the object mapper, so it's quite powerful. But for the demo that maybe one day I will be able to show to you, we also implemented the geo library for DynamoDB. So the geo library is a library that we built that is available on GitHub that is using GeoHash to run geolocalized queries on DynamoDB. So I don't know if all of you are familiar with GeoHashes. GeoHashes work in this way. So usually to specify the location of something on Earth, you need two numbers, latitude and longitude. With GeoHashes, you need only one string or one number. How does it work? Let's imagine that the Earth is not a sphere, but it's a cube. So at the beginning, if you want to specify where the location of this object is, you choose which of the 6 faces you are on. So let's say that I choose A. Then I take this square, as you can see on the right, and I start to split this square in 4 parts. And I say, in which of the 4 parts is the user? In this case, let's say that I want to map the first red dot. So it's in section 2. Then I split in 4 parts section 2, and I say in which one it is in section 2. Then I split in 4 parts this other section, and I can go on with us, and the GeoHash will get longer, depending on how much resolution I want in localizing the object on the Earth. So this is strange, because if you think we replace 2 numbers with only a single number telling you where an object is on the Earth. So using this, you can use this information with DynamoDB, but DynamoDB requires that the first field of the primary key is a hash key. And the hash key cannot be queried by range. You need to query an hash key directly. So the trick here is that you create a cell. So depending on how much resolution you use when you run the query, you can define a longer or shorter cell. And this cell is actually just the first, usually 6 numbers of your GeoHash. So you have a complete GeoHash. You take the first. Usually you take the first 6, it depends really on the resolution that you usually run, and this becomes an hash key. So our library, when you run a query like tell me all the objects that are inside this rectangle, or of the objects that are within this radius from this point, will map that into GeoHashes. We'll manage the fact that GeoHashes, they have borders, so they are not linear, because if you take a point that is between the border of section 1 and section 2, you will have to manage the fact that a radius can cross over between different GeoHashes. And then we'll extract the list of cells that can be affected by this query and run in parallel the queries on DynamoDB with a range on the remaining part of the GeoHash. So this seems very complex. It is not, but the nice thing is it's completely managed by our library. So you just need to put latitude and longitude, and you get the results. But within DynamoDB, this is how it works. So in this way, you can use the DynamoDB to run the GeoHash queries. You cannot run these queries directly to DynamoDB. You need a server that will handle this translation with the library. So this is the very tiny backend server that this application is using. But it's a completely stateless server that you can scale horizontally because there is no data. It's actually taking your information, using the geo library to run the queries in parallel on DynamoDB. And in this way, you can run geolocalized queries. So if you save a location DynamoDB, you have to implement the geohashing algorithm to write this data. You can use a global secondary index on the table for the cell and the geohash, and then you can run GeoQuery directly from the device. And you can ask to DynamoDB, tell me all the objects that are within me or that are closer to this point, and it will run. Of course, it's a little bit heavy on DynamoDB because depending on the number of cells that are affected by a query, you have a number of parallel queries that you get. And if you know DynamoDB, you pay for a table the throughput. So you must ask for a specific throughput for a table. So how many queries per second do I want? And of course, you have to take care of this. So if you have 10 users, and these 10 users will run 10 queries, but every query will use 10 geohashes, you actually have 100 concurrent queries on DynamoDB. So you have to be careful on the throughput. You can also have multiple indexes with different cell length, so that, for example, depending on the scale of the query, you can use the index with a cell that is shorter. And if a cell is shorter, it's bigger, so you have less parallel activity, or longer. So instead of having just an index with an hash key of 6, you can have another one with an hash key of 4, another one with an hash key of 8, for example. It's a little bit of redundant information, but it helps you scale correctly. And then, depending on the size, so the scale of the query, you use the right index. So now we saw also how to use DynamoDB directly from the device. Let's review quickly the scalability and the cost. I'm starting to master. Let's see the mobile analytics. So mobile analytics is interesting because we have a free tier that tells you that every month you have 100 million of free events. So that means that every month, the first 100 million of events that are sent from your application are for free. And this is always, it's not like Cognito for the first year. So it means that if you start to paying something, probably you have a lot of events to trace, and it's a very good sign. Above this threshold, you pay $1 for every million items that you send to us. So it's quite interesting. So if you want to test it, it's really for free unless you have a very large scale production environment. And the scaling is completely managed by us. So you don't have to store data, to provision storage, to think of the scalability of the web server that will receive this information. It's just send information and get the results. For S3, it's almost the same. For S3, you pay only the storage. So there is no issue with scalability. You pay only for the storage that you use. The only issue with scalability is if you have an object that is downloaded concurrently from millions of users, you should not use S3. You should use CloudFront, so a content delivery network that is caching and distributing the content. So if personal usage of S3 or small scale is OK, if you have the same object to be distributed to all your users, like I can imagine a software upgrade that is downloading some new images from your game, probably you should implement a content delivery network. It's much more effective for your users. And the last point was DynamoDB. For DynamoDB, scalability is managed by us. As I told you, for every table that you create on DynamoDB, and for any index, any global index that you add, you can specify the throughput. And the throughput is expressed in number of queries per second, so number of reads and number of writes per second. It's not based on I/O per second, so you need to know how the size of the storage is mapped to the attribute. It's managed really on the size. There is a maximum size over which you pay more, but let's say that for normal usage, you really pay for the number of reads and writes per second on the items. So it's quite simple to scale. And for example, we often talk about how Shazam is used in DynamoDB, and when they run a promotion, an advertisement during the Super Bowl, so they were expecting a huge quantity of users going back to Shazam because they did this advertisement. They just increased the throughput of the table to 500,000 writes per second. We managed the scaling with our platform, and then after the peak of the advertisement, they could lower down the number and stop paying because, of course, you pay by the throughput. So the scaling is really managed by us. And one interesting thing, we also provide metrics for how much a table and an index are used via CloudWatch. And more than one customer of ours released a free script on GitHub that you can use to auto-scale DynamoDB. So this script will monitor and listen to notification from alarms on CloudWatch. If they see that they, for example, this is configurable, but if you reach 80% of your throughput, you can increase your throughput. If you see that you are very low in your throughput, so you're using like 20% of your throughput, you can lower down the throughput of the table or of the index. In this case, everything is managed automatically, and you can really optimize the cost. For the cost of DynamoDB, as I told you, you pay the throughput and you pay the storage, of course. So with this, I think we can end the second part, still a theoretical dissertation on mobile development, no live demo. I'm sorry for that, but I will try to work now in the break, and maybe in the next and final session, we will see something live. Thank you. So Jinesh will save my life today and will show his own application that will at least give an idea of what you can do.
Yeah. So thank you again, Danilo, for doing this. He has lots of weeks of work done, so we are going to see what we can do. But what we have done here is, I'm on the product side, on the mobile services team, so feel free to ask me any questions you might have. I've been in AWS almost 8 years, focusing on all AWS services, and have been a technology evangelist as well. So I built this small little game to kind of give you an idea of how you could use all the different services that Danilo talked about in a context of a game, right? How many people are game developers? Oh, few. That's true. That's cool. So this is kind of going to be fun, as well as the entire source code is available on GitHub, so you can download, play with it, see how it works, and so forth. It uses Amazon Cognito for identity and synchronization. It uses Kinesis to store certain data, like clickstream logs. It uses DynamoDB to store the high scores of the game. It uses Amazon S3 to download dynamic game assets. So I'm going to show a part of those demo and kind of walk you through the code as well to give you an idea of how it all works. So in an effort to make everything work in an emulator, let's just see how the game works first. So this is my game. As you can see, and as Danilo was talking about earlier, that there are different ways you can integrate your authentication providers. We have out-of-the-box support for Amazon, Facebook, and Google+. And you can also have what we call unauthenticated identities. So you can zip through the game without having them to log in, right? So that creates a unique identifier, and it kind of gives you an experience so that your users don't have to go through the game. But let's go for from the side of things. Let me just log in through Facebook, and this will be my Facebook. Because I have integrated Facebook as well as Google and Amazon login providers directly, and I'll show you the code later on. It's basically going to use the same SDKs that is available today, right? Your users is what really matters. Which login provider they use, they don't matter. So and that's the power of Cognito, that whether they're using any login providers, you can have an ability to, your users get the choice basically to pick any login provider. And we'll merge the credentials, merge the identities at the back as well, based on the identities that you have. So let me just log in. And it will use the Facebook SDK, because I've integrated the Facebook SDK in that small little game, and then it asks for authorization. So my game is very simple. It's a snake game, where the snake eats the apple gets, the apple increases as every level you go on the game, right? I'm using a Fibonacci sequence, so every level gets difficult later on, so number of apples increase to meet that particular game. As the snake eats the apple, the snake gets a little longer, and it gets winding and gets faster, so the game gets tougher and tougher. So this is a more typical, simple, I would say, and hello world application of a game using all the different services. So as you can see, like, from the game perspective, let's play a game because it's kind of fun to play a game on stage too. So, so as you can see, it's a simple game mechanics. There are just few graphics. I can swipe. I listen to my swipe, and I. So that was my cool audio as well. So what you just saw was basically a simple game that kind of just shows how the game matures over time. So in this case, I'm just going to now like stop the game. I'll show you the code, and then I'll run the whole thing, reach a particular level using Facebook, and kill all the emulator again, start afresh, simulating in another device, clear the cache so it's a brand new device that is there, and then I'm logging again so that it will log back onto the same level that I left off. So it's basically if you had two devices, and whether their devices are Android or iOS or Fire Phone or whatever, they can log in to the same application and synchronize that data. In this case, I'm synchronizing the level and synchronizing the high score that you have reached. So and I can also synchronize the actual game state. That means what is the position of the game itself, and of the snake itself, and how many apples were there in the previous game. So you can literally pause the game and resume it from the next game, all doing Cognito data synchronization. So you can store all that data in the data set that Danilo was mentioning earlier. So let's just quickly walk through the code first, and I will also run this one more time. So the code is extremely simple and easy to understand. By the way, everything is available on GitHub, so you will be able to. And can you guys see this? Excellent. So the game mechanics is basically all under the game folder. Game controller, game level, a simple game model which basically shows the movement of the game. Now I'm having a game state listener, which is basically a swipe that is happening. Every swipe I do, the snake changes its direction, up, down, left, right. There's a game view, there's a snake object, direction, and the swipe listener. Very simple, and that is just the game itself. Without any cloud component added to it, it can work in itself. So if you have a client-side game and that you would like to add cloud capabilities on it, this is the way to kind of get started as well. So in this case, the game itself is very simple. Now, my AWS folder, if you're an Android developer, this will be pretty easy to understand. I have all the different basic simple asynchronous tasks that I have created for Cognito Sync, DynamoDB, Kinesis, and so forth, because they are all async tasks that you are making to AWS. In case of Cognito, now you don't need to create an async task because it's always working to a local cache first. So it is a SQLite call to the local store, and then so it's extremely fast, it's easy to use, and then later when you do dataset.synchronize, that's when it actually synchronizes your SQLite to the dataset in the cloud, and then it will synchronize to other devices. So as you can see, I have a simple helper function, which I'll kind of show you later, but there are basically 4 game Android activities. The first one is a login activity, which basically uses Android, it uses the Google+, Amazon, and Facebook login providers, and I'll show you the code on that. And then it has a snake game activity, which is the actual game itself. And then once the game is complete, now there is a game over activity, which basically just shows the score that they have reached, and now I have an ability to synchronize that data, or manually synchronize the data, or take a screenshot. How many people have played 2048? Oh, few, cool. So I have in this particular game a feature where once you reach a particular score, just like 2048, when you complete that game, you can share a screenshot with your friends, right, of the score that you have reached. So it's and what happens behind the scenes is basically when you click a button, it takes the screenshot of that last image of your game score and uploads it to S3. So you can share it with your friends as well. So that's the functionality of the game. So basically, just to summarize, I use S3 for uploading the screenshot, S3 for downloading the game assets, DynamoDB for storing my high scores and my shared data objects, Cognito for my level and score, Cognito for also identity broker, basically Google login and other login providers. I'm using Kinesis to store the clickstream logs. So I basically all these tasks are available in here. Now, the main main function that you need to initialize, and this is just a helper function, right, is init. So as you can see, Cognito is a gateway to AWS for all the different services when you want to connect any mobile service, any mobile device wants to connect to any mobile service. The Cognito becomes the gateway. So I do one time provider equal to, I instantiate the provider class, which is the caching credential provider, and then that's the credentials that you would provider that you will be using for all the different services that Android that you would like to use throughout the game. And so I'm using this particular provider to initialize the Cognito sync capabilities. I'm using the same provider to use S3. I'm using the same provider for DynamoDB and analytics and S3. I didn't mention I'm also using analytics service with just one line of code in your console. In our Android code, we start getting all the session events that Danilo was showing, all the beautiful graphs that with literally just one line, and I'll show you which line that is, that will start sending all the session data to Amazon Analytics service, and it will, you will see monthly active users, daily active users, and all the things that really matter to your business. So that's about it. This is the only class that you need to kind of, it initializes all the constructors that you need, and then there are some basic things that I have, a getter, setter methods, and other elements that will help you over here. So now let's just see a very simple thing like a download task that Danilo was mentioning, that you could use this to download the game assets dynamically. So how this works is basically, I have wrapped this component into an async task. How many people know about asynchronous tasks in Android? Okay, cool, a lot of people. So it is a way so that when you're trying to access any cloud service, you want to make sure that you are not using the main network thread. So otherwise, it will give you a network thread exception because it's a background task. So you always wrap this into an asynchronous task, and then the only function. So this particular function, what it does is it takes it goes into it when the game launches, it looks up for a particular file, archive.zip, in one of my folders in S3. It downloads that particular folder, which has all the game assets. For example, the graphics that you just saw, the Apple graphic, the snake graphic, the background, and all that stuff, right? All the game assets that is related to my particular device that I am testing. So I can have different devices and different HDPIs and different densities that might be there, and have their graphics not bundled into a particular APK file. I can dynamically download those assets as well. And this is a great best practice, that if you're building a game for all the different Android devices and all the different tablets and different form factors, you don't want to bundle everything into one APK file. You want to understand and do device detection, and then only download the game assets of the densities for that particular device dynamically. So it's not bundled because there's APK file has some megabyte restrictions and so forth too. So in this case, I'm downloading the zip file. I am unzipping the file, and I'm using the local storage, the external local storage, to upload. And then if I say, and I'm also checking that if the file has changed from the last time, from the last metadata, then which I can do a simple head call request to S3 and find out, okay, the file has changed, download the new game assets. So I will download that game assets, unzip it, and then store it there and tell the game to use those new game assets. So let's see that in functionality. So in this case, let's for the sake of it, let's now kill this. Again, I want my demo gods to be with me today because it was a last minute. I'm just going to clear the cache so that it is a fresh new application that you can see. So this time I'm going to use, as you saw, the previous game had a black background, had a certain level, certain style of the game itself. But most of the game providers today have a mechanism by which they want to continuously innovate and tell their users that there is a new game out there. So if you're using Angry Birds and Christmas is around, they want to have Angry Birds Christmas edition. So you can change the game assets a little bit, but and it's sort of a brand new game, but it gives you a very easy way to update the game assets dynamically. So that's what I'm going to do. And this time I'm just going to use Amazon login for the sake of it. And I'm going to so in that, it's now going to download the new game assets from S3. It's unzipping those assets for me. And this is a typical thing. If you're using Jetpack Joyride or Clash of Clans or any of those games, you will see that, that you will have a big download button that they're downloading game assets. So what that now happened is that now I'm having a FIFA theme for the entire Snake game, right? The apple became the ball, the snake became the snake, and the background is the background of a football field. So now everything remains the same. I'm still going to play my game. So I'm dynamically downloading the game assets. This is not working, but it's just kind of crashing for some weird reason. But basically, you get the idea that it will start. The game will start working on I'm not sure why it's crashing, but basically, you got the idea about how a demo would work in this case to see a synchronization that will happen, as well as how the game downloading the game assets from S3 itself. So let's see that code just to give you an idea of how the code is. And then I'm going to go to mobile analytics to give you an idea. So S3 download task is a simple constructor that initializes the same Amazon AWS client manager.get manager, the same class. And all you have to worry about is this, and as I said earlier, I'm looking for any new resources that were available. So I go fetch the new resource that is available, and I had uploaded a new asset before this game I started. So to look for the metadata, and I look for whether the metadata has been last modified and what that time is. And I will check that modified date to see, okay, it's a new file, unzip it, and get me a new game asset. So you can upload and get new versions dynamically without changing the App Store app. It's just downloading the App Store game assets without have to worry about uploading a new version of the app. And then that is it. As Danilo was mentioning in the one of the slides on S3, this is the only line which you have to worry about whether for doing anything, which is manager.download and give a folder where you want to download that particular zip file. So in this case, it's downloading, it's doing all the things like managing intermittent connections. If it's a very big zip file, it will unzip, it will do multi-part download, and it will get you the files and do all the other elements. You don't have to worry about it. It will do managing retries. This is all done by the SDK itself. So SDK has the benefit of managing all of that too. And so that is it. And I am just basically updating the progress bar because it's a UI element, and based on the text, like it's checking the text files and based on the status, and that's about it to kind of get the downloaded zip files. So in this case, it went to S3, got the new files, got the FIFA theme files this time, and then I logged into that part. So now let's see a quick way of just like going through the mobile analytics part. So in this case, like I'm initializing an analytics constructor. So mobile analytics manager equal to get or create new instance one time. So it's a singleton that you instantiate, and you pass in certain passing the actual context. And you're passing the context object because you want to use the local preferences of Android to get the data and also use the SQLite. The SDK manages all the SQLite caching for you. So even if the application is not being used, it will cache or internet connection is not available, it will start collecting and caching all those requests in the SQLite, and you will never lose any events that your users are doing. And when the connection is available, it will upload all of them in batch. So it does all the batching and for you. So this is one line of code, and then in iOS, literally you don't have to do anything because you are doing a default configuration. But in Android, you have to add one other line, which is when I start my game activity and doing my pause and resume. So there are these two callbacks or implementations that you have to do. Analytics.get session client and resume session, and then analytics.get the session client pause session. So why this is because when you are resuming and pausing the session, it will try to make a call to S3 to the analytics and try to upload all the events to the analytics service. And then you can see all the beautiful graphs that you have about what time the users are using, how much the activity was, how many times they came back, what week they came back, retention analysis, and so forth. I also have things like custom events. So in this case, I wanted to check the game that how many people are reaching a particular level in my game. So how fast, how slow people are moving from one level to another level. So in this case, I have added a custom event. That means something very, very focused for my app, something that is related to my app itself. I can also track that using custom events within the mobile analytics framework. So in this case, I will do event client equal to new event client, and I get the event client, and I'm going to set the level or the speed of the game where you are at, and then I'm going to record that event. And that's it. Now I will go to the console, and I can see how many levels people are sort of reaching. So I can adjust the game mechanics a bit to make it more easier or make it more tough, and kind of increase my monetization or revenue or whatever that you are focusing on to build that game more effectively for your users. Because you want to continuously iterate and keep on iterating as your game produces and so forth. So all these game providers, whether they are these large game providers like Clash of Clans and Supercell, to the small game providers like Flappy Bird, they are all sort of using similar mechanics in some way to build out this game. And this is not just related to obviously a game, but it's also any app. And the code that I'm actually showing you, this part of the code, is completely reusable for any part, any game itself. So any application itself, because it's just plain code that interacts with the AWS part. While the game part can be replaced completely with your app itself. And all you have to do is add the activities that are sort of these 4 activities based on your application itself, build out that complete environment for doing this over a series of time. Last but not the least, let me kind of show you the DynamoDB element put task that Danilo was focusing on as well. So as you know, similar to S3, DynamoDB is also a asynchronous task. So in here, there are 2 ways you can use. DynamoDB has what we call an object mapper. So your actual Java Pojo object can be mapped directly to a table within DynamoDB. So your properties of your object will become columns in DynamoDB. So you can do that and use the object mapper, or you can use the low-level client to just store what you want to store. So for Cognito, you would store identity preferences of a particular user itself. So for example, whether they have turned off push notifications or not. So those data will stay in the Cognito sync store. While everything in the DynamoDB side, it will be more focused on shared data models. So I want to store high scores, for example, so that I can list all the people and all the high scores, and all that data goes into DynamoDB. So you can have these two sync stores. One is a sync store, very focused on identity preferences, and this DynamoDB will be more focused on shared data models, so shared data usage. So as in this case, I'm again just initializing the constructor and getting the singleton object, and all I have to do is take the user ID, I'm taking the record ID, which is in this case high score, and then doing a put item. So I'm taking the item, I've reached that particular level, I instantiate the constructor, and I'm just getting, taking that attribute value of high score and the username, and then just putting in that particular high score database in my DynamoDB database. Now, if DynamoDB works really well when you are storing massive amounts of data, you don't have to really worry about scaling the database. Your mobile device is interacting directly with the database service without you having to worry about any middle layer web servers or app servers or doing SQL queries or whatever. And that is the beauty about using a serverless computing, basically, that your mobile apps are directly connecting to cloud services. Do not have to worry about it. When your user base grows to thousands and millions of users, you just have to click a few buttons in the console to say, I want 10,000 writes per second, or I want 10,000 reads per second, and DynamoDB itself will scale and distribute your data across multiple pieces of hardware in multiple availability zones, so you get the same what we call provision throughput for that particular game. So it's extremely easy. I highly recommend you using a database like DynamoDB directly from the device itself.
Yeah, and you remember the policy document that we saw at the beginning when you can set up the role of the user? With DynamoDB, you can set up that a user only can read and write records that have the user ID in the hash key. So you know that the user is only writing his own data and reading his own data, so that's quite powerful.
Right. So that's about it. It's very easy. This code is available on GitHub, so feel free to download and play with it. It is also available as our self-paced lab in one of our rooms in the hands-on lab. So you can actually go through the lab. It just takes probably 35 or 40 minutes. And actually, it has those things, cut and paste your code from here to here. So you can actually learn hands-on way and actually build this game that we just have in a complete environment on an Android machine, an Android environment itself. So I highly recommend you, if you want to go hands-on, that's a great way to kind of get started as well. So again, this was just a quick run through of the code, but
the idea was to show this when we were proceeding during the presentation on the application, but thanks to Gines, so we saw something live and how you can really code these features inside your application.
Cool.
I think it's
awesome.
really important.
Thank you very, very much.
So let's continue my theoretical presentation on how to develop on mobile. So let's see the third part. So in this part, we will see how to use mobile push messaging using Amazon SNS, how to upload and use data in real time using Amazon Kinesis, and how also to run your own backend. Because if you, because if you have even a small instance to manage, you can still avoid to manage the operating system and everything and use services like Beanstalk that will take your code and implement all the infrastructure for you. This is what I did for the GeoServlet. And then we will review scalability and cost and do a final wrap-up. So starting with SNS mobile push. So mobile push is something that you really must use in your application because 65%, but sometimes even more, of mobile apps are abandoned within 90 days. And this is something that analytics will help you track with the retention panel. So how can you avoid that the application has been abandoned? Of course, you have to develop a good application with good content, but users will simply forget that they have the application. So you can engage them back with mobile push. And we are now very used to receiving this kind of notification on our mobile. You can have generic notification, customized notification, and this will bring them back to your users. Typically, there are 3 use cases here. You can have a broadcast to all or a very large part of your users of the same message. You can have a direct message specific for a single device, or you can do closed loop. So you analyze your customer behavior, and based on their behavior, you can send customized message on a segment of your users, maybe the users that are not using a new feature or the users that are not playing a game. Let's start with broadcast. An example of this is when you release a new feature or new content, and it's very common for a game to for example, send a message that tells a new level is available, you can go here, it's a free level, or maybe it's something that the user will purchase, but it's a good way to promote the content. You can also send messages to all the active, to a very large segment of your users, all your active users, or the users that stopped using your application in the last week. Or you can do segmentation, like all the users that are coming from a specific geographic location, or they spend less than $N per month. So it's really cross-border with marketing. But it's important because it's the way you can tell them that a new episode is available, that they can keep the stick going, that your character is missing them because they are not coming to play with the game in the last few days, and so on. This is really a nice way to interact with your users. And then you can go direct. So direct means that you can really tailor a message to a specific device. So you can use this for messaging, so players can exchange message across them using your platform. Or there are turn-based activities, so you can tell to a user that they must do something because otherwise the other players are waiting for him. Or also any administrative task that you may have and that you want to interact with your user with. So you can invite a specific player to your game. You can give a warm welcome with the name of the users that you get from Facebook. It's still impressive to see your name in a message that you receive. Or you can tell a user that the subscription from some premium content is ending, so if they don't act, they will stop playing in a few days. And closed loop means that you can broadcast or send direct notification based on really anything that you can happen. So you can play with different times of day, the life cycle of your app, so depending on when they are in the life cycle. So it's really something that you can flexibly manage. So let's see how does it work. So traditionally, you have to talk with a platform service that depends on if you're using Google, if you're using Amazon devices, if you're using Apple devices, Microsoft phones. In China, Baidu is the service that they are using for Android phones. So this platform service will have some peculiar features, and you will have to register the device to the platform service and listen to the feedback, because this is somehow similar to email. So the platform service will send message, but will also tell you feedback, like this device is not responding, is not listening to messages, and so I am disabling this device, and you have to understand what is happening, maybe send in your application, try to resubscribe the user, so it's always not easy to manage. And you have different APIs, because of course Apple, Google, and Amazon, they have different ways to interact, different features, and different way of managing the feedback that they send you on the users that they manage. So at the end, you will end with something like this. So you have your application, your cloud application that wants to send message. They have to speak to different platforms. Each platform will speak with a subset of your users. And probably you will start to develop something to solve this. So we will write your own middleware to to have a single interface and to speak with these providers. This is exactly what we want to avoid, because if you develop this, okay, you have a middleware that will abstract you from any specific platform, will maybe also manage tokens if you put this into your code, but SNS is already doing that for you, so it's much easier to implement, because it will have much less operational complexity. We will not have to manage a new component, to develop, to maintain, to keep updated with the new features. So as I told you, SNS Mobile Push can interact with different platform providers, so Apple, Google for Android users in China, Amazon for Fire OS devices, and Windows for Windows 8 mobile and desktop, and Windows 7 mobile. So with SNS, you can really choose, because you pay for the messages you send, so you can send a few messages to a few users or scale to millions of messages to millions of users very easily and very quickly. You don't have to do any provisioning. And we also manage new features, like for example, when iOS 8 introduced new interactive notification, they were implemented in the platform so that you can use that easily without having to update your own middleware. So what happens is that SNS will be using the credentials. So the first step is the registration with the provider that is still direct from the device. But then SNS will manage the token for you and get the feedback from the provider. So what happens is that you don't have to interact with the provider after the registration, and also if there is a change in the token. So sometimes the provider will deregister a token of the device and create a new token. Everything is managed transparently by SNS. You still have a single endpoint that is preserved, that is the endpoint that SNS will provide you. And then you can do direct publishing, so go direct to send an SNS message to an endpoint, or broadcast using topics. So topics is like a list of endpoints where these endpoints can subscribe. Now the limit is very high, so it's virtually unlimited, the number of devices that can subscribe to a topic. And publishing a single message, a single API call to a topic will broadcast this message to all the subscribed devices. And eventually, you can have different topics where you subscribe users depending on the geography, on the activity that they do. They play during the day, they play during the night, the specific product, of course, every interest, every information that you have. And then you can use these topics where large segment of your users are subscribed to send messaging and do engaging activity on them. You can use the same syntax, the same message for all the platform. Or if you want to use platform-specific extension, you can do that. So you can create the base message, and then you can add the extension for the specific implementation, like the new features that I was mentioning for iOS 8 that you have to add if you want interactive notifications. So to start this quite easily. So you have to register your app to the identity provider. They get you back a certificate or an API key or a token, something that authenticates you with the provider. And you also, with this, you create an application within SNS, and then the device can register itself, and you link the application with a create platform endpoint API call. We also have the possibility to batch load your current device using a CSV file. So if you already have like a device that you want to move from direct management with a provider to a management through SNS, you can get the list of the device, pass us this SCV file, and we load the file. Or the device can also subscribe by themselves, because one of the service that you can specify in the role for Cognito is SNS, and you can tell that this role allows the device to use the create platform endpoint API call, and the device can register themselves with the Cognito credentials. So everything is managed by the device, and you find them automatically registered on SNS. You can also add the possibility to subscribe a topic automatically. So maybe automatically, depending on the configuration, they will subscribe to one or more topics. This is an example of the device registration code. So you create a platform endpoint request with the ARN, so the Amazon resource name of the application. So you will have an application for Google, one for Apple, and one for Amazon, and the device token that was passed from the first registration. And since this point, everything is managed by SNS. You can send message from the console. So if you want to do debugging, you can use the Amazon console to send a message, and that was something that was planned to be shown live. Or you can use the server-side APIs. This is an example from the Boto library, so the Python SDK for AWS. So you just connect SNS to the region. So I chose US West 2 in Oregon, that is quite close to here. And then you send a message to a target Amazon resource name that is the platform endpoint that you get from the device. This is the unique endpoint that is fixed and will not change even if the provider will register and register the device internally. So we are going on in our virtual and theoretical addition of features to our application. So we see that now we also add SNS mobile push. And the last step is to stream data in real time from the device. So what we can do here is to leverage Kinesis. Kinesis allows you to send data in a scalable way using an infrastructure that is managed by us. You can create one or more streams. You pay by the streams that you create, and every stream has a throughput. So every stream can inject up to 1 megabyte per second and 1,000 writes per second. So it's quite huge just at the beginning, and it costs a few cents per hour. So it's very scalable. Then on the back end, you can have an application consuming these events. Now that we announced Lambda yesterday, the new service, you can also have a Lambda function listening to the events and starting an event-based processing depending on the event that you receive. And so you can also avoid having an EC2 instance in the backend because everything be managed by Lambda. And Lambda has also a very interesting free tier per every month, so probably you don't spend nothing, especially in development. And usually what you do, you analyze your data, you can have real-time metrics, and then you store your data on S3 if it's not structured, or on Redshift if it's our data warehouse database for further analysis. And in the example that I was giving, this can allow you to do even more sophisticated user behavior analysis than the mobile analytics allows you. So if you want to store information that is outside of what mobile analytics allows, or you can also upload any exception that you get in your code. This is very useful because you send the whole stack trace, and you know if users are having an issue inside the application. Maybe the user doesn't understand that there is an issue because the exception is managed, but you send the exception via Kinesis to your backend, and then you can analyze and understand and reproduce the bug. So the Kinesis connector allows to do that from the device very easily, and it's caching the data locally. So if there's no network connectivity, as per Cognito, you will still save data locally. And then when there is network connectivity, you can submit the events back to the platform. This is how it works. This is the Kinesis recorder on the mobile. You need a unique directory that it's just a string that you must define to have a unique directory where you cache your file locally on your device. Then you create the recorder. You pass the Cognito provider credential. Of course, the role will allow this user to submit events to a specific stream. And then you create, specify the region, and then you create you get the directory. Mode private is what we suggest, to have a private directory for your application. And then with the recorder, you can save record, and you have just to take any string. You have to transform the string in a byte array, but just get bytes. And then specify the stream to which you want to send the information. Usually you can have a single stream or more streams depending on how you implement your application. Then you can get the disk byte limit, so how much space do you have locally on the device, and how much space is actually used by the cache. So you can eventually also understand if you are filling up the cache, probably you are creating too many events. It's better to reduce the number of events. And you can get also the storage size accessing the recorder config through this method. So it's quite flexible, very easy to use. And what one can implement is that you can create a couple of an helper class that will submit maybe specific data, like an exception. You format it in a text file. And usually JSON is what we suggest to use as a payload because it's something that you can reload on the other side and recreate object very easily. So we completed our features. I think that if you think of what we accomplished and with very few lines of code, as Gines also showed to you, you are really using a lot of features without having the hassle to implement all this, and having more time to focus on what are the unique features of your application. So going back to Kinesis, if you don't use Lambda, probably now I would use Lambda, you can have a backend application that is managed completely by our Elastic Beanstalk service. So Beanstalk at no additional cost, because you will still pay only the resource that you use, will create automatically the environment for you starting from the source code. So if you have a backend written in Java, PHP, Python, any of this language, or even a Docker container with your own customized environment, that you can just pass this to Beanstalk, and Beanstalk will create, for an application, you can have more than one version. You can create one or more environments, like a test environment and a production environment, or if you want to risk just a production environment. And then you tell to Beanstalk, deploy this version into this environment. So you can deploy version 0 in the test environment, test it, and then automatically you can tell them deploy version 0 also in production, so that you can, everything is automated, so you don't have human error, because sometimes it can happen in human deployment that you have some discrepancy between the environments. Or if you want, you can scale up the test environment and swap the environment URL, so it's very transparent, powerful way to manage this. In our deployment, if you remember, I was using a backend application only for the geo queries, and it was completely stateless because I was running queries towards DynamoDB. So I can add and remove nodes automatically using autoscaling, and I don't have to manage the size and the scaling of my backend, because it's managed by Elastic Beanstalk. Elastic Beanstalk will build an environment that you can build development environment with a single instance, but if you go in production, you can build an environment with an Elastic Load Balancer, an auto-scaling pre-configured for your needs, and CloudWatch to monitor the environment, and alarms that can be used by auto-scaling to decide if to add or remove instances based on the usage of the application. So it's already, everything is pre-configured. You have a web console that allows you to see that, but now I think we have not enough time to see that, but it's really nice. Let's review scalability and cost. So SNS, you get 1 million of messages per month for free. So the first million of messages, of mobile push message that you send every month is for free. And if you go beyond 1 million, you pay 50 cents for every other million of message that you send. So it's quite cheap and allows you to avoid to manage all the interaction with the custom providers. Kinesis, you pay by the stream, and you pay by a few cents per hour per stream. So it's quite cheap. And one stream, as I was telling before, it can inject 1 megabyte per second and 1,000 records per second. And Beanstalk, you only pay for the resource that you have. So now, as I told you, probably I would switch that to Lambda, but if you use Beanstalk, you only pay for the EC2 and the ELB resource that you're using, and it already implements the auto-scaling functionalities that allows you to only use only what you need in production. So what app did we just theoretically build? So these are the features that I was mentioning at the beginning, and this is the overall framework. It's nice if you look at the overall picture of the application, because you have on the client side, you directly can interact with Cognito with the key value store for data synchronization, so identity and synchronization, mobile analytics, the S3 connector to go directly to a bucket, DynamoDB connector to manage very easily the connection to a database, the Kinesis connector to stream data. I was streaming the location of the users that you can maybe use to send messages back and engage the user, and any crash dump that you have in your application, and SNS mobile push to self-register the device to receive the notification. On the server side, you can access Amazon Mobile Analytics to see the dashboard, so you can monitor how the users are using your application, and you can know if they really are using a specific feature or not. And you can also interact with Kinesis to get back this feedback, so the location of the users, maybe the crash dump that you want to analyze. And with SNS Mobile Push, you can also send messages without having to worry if this is an Apple, an Android, or a Microsoft device. to engage them back into your platform. So the takeaways are, there's a lot of things that you will have to do again and again for every application. We can help you to avoid this repetitive task using our SDK. It's integrated, it's available for iOS, Android, and Xamarin in developer previews if you are from a C# background. We cover a lot of these functionalities. And if you want to learn more, AWS Amazon.com/mobile is our mobile portal. From there you can reach to all the information that I told you today, and more, of course. This is the Android developer guide. It's not the manual, it's a developer guide, so it helps you start with all the services from Cognito, identity, synchronization with real example of the code. So it's what I recommend you if you want to build something based on what we saw together. And that's all. Thank you for your patience, especially for the lack of the demo.